In this video, I'm going to show you how to graph a tangent function, which is kind of one of the trickier functions to graph. Definitely trickier than sine and cosine. So we're going to have about 3 steps here. Again, different than the sine and cosine. First step is that we want to find and label what are called vertical asymptotes. If you remember that vertical asymptotes are vertical lines, they're imaginary, they're invisible. They are vertical lines that our graph will approach forever but never touch. So we're going to have some of those in our graph. We're going to want to find and label what are called the midpoints of our graph. And we're also going to want to find the period and the x-intercept. And once we've found those, we can label it and connect our points, and we'll be able to draw the graph there. So that's kind of 3 steps to graphing a tangent function. In general, this is the form of a tangent function. A is always going to be a number or a value in front of the function. B is always going to be a number or value in front of x. And we're going to have equations to find our asymptotes, midpoints, using a and b values. So let's start with the most basic tangent function, which is tangent of x. We're going to want to find our left asymptote, I call that the LA, and our right asymptote. And they're actually going to be the same equation, except the right is going to be a positive value on our graph, and the left is going to be a negative value. But the value will be the same, they're just going to be opposites of each other. To find the vertical asymptotes, we're going to use the following equation. Pi over 2b. And that will always be the same for every tangent function. So we're going to have the positive one. We're also going to have the left side or the negative value. So you can evaluate it like that. Equations for our midpoints are going to look like this. Midpoints are going to be coordinate points, so we're going to have an x and a y value. The x value will be found by doing pi over 4b, because it's going to be halfway between our asymptote and the origin. I'll explain that a little bit more when we get to graphing. The y value is always going to be that a value in the function. So that's where the a comes into play in tangent. So you're going to have the right midpoint or the positive midpoint, and you're also going to have a negative midpoint or the left midpoint, which is just going to be the same values but negative. And the last equation we need, it's kind of a lot here. But the period of a tangent function can always be found by doing pi over 1b or just pi over b. So slightly different than sine and cosine, but there are the equations for what we're about to do. Alright, so getting back to our example here, tangent of x. To find the left asymptote, I'm going to do pi over 2b. And since b is 1, that's just going to be pi over 2. So my left asymptote is pi over 2. I can draw that on my graph using a dashed or imaginary line at the value where it crosses our x-axis. And that value is negative pi over 2. My bad. The left value would be negative. Okay. The right asymptote is going to be the same, but positive. So at positive pi over 2, I have my right asymptote. And if we want to talk about the outputs, the possible y value, given that input, it's going to be undefined because our graph will never touch this line. So I can't ever have an input equal to this, but I can have everything close to it that approaches it. So our y values are going to be undefined our outputs are going to be undefined at those asymptote locations. Okay. The next thing I need, the other two key points are going to be midpoints, the left and right midpoint. And I find those by evaluating pi over 4b. Since b is 1, that's going to be pi over 4. So right here, negative again, almost forgot. It's going to be negative pi over 4. And if you think about it, it's going to be halfway between the origin and this asymptote. So half of this value is pi over 4. So you can always, if that helps you remember the equation, it's always half of the asymptote, so you're going to multiply by 1/2. Over here, my midpoint is going to be positive pi over 4. And the y value, or the output, is always going to be my a value. So you could plug this in and find the tangent of negative pi over 4 and the tangent of pi over 4, but it will always just give you this a value as your output anyways. So it's a good little shortcut, whatever the a value is. So the a value in this function is implied that it's 1. So that's going to be negative 1 on the left side, positive 1 on the right side. So if I draw some values here, let's say that this is 2 and this is 1. It's negative 1 and negative 2. I can plot my midpoints now. My x value is x over 4. Y value is 1, so here's my midpoint in my graph. Down here, right here, would be the other midpoint, negative 1 pi, or negative pi over 4, then negative 1. And so now I can kind of draw my graph. The x-intercept is always going to be in between my asymptotes. So in this case, the origin is actually my midpoint. So 0 is my input, 0 is my output. 0, 0 coordinate pair. And now I can connect the dots. I know that it's going to cross through there, cross through my midpoint, and approach this line forever but never touch it. So it kind of has a little curve there. Over here it's going to cross through this midpoint and approach this asymptote forever but never touch. And so what we end up getting with our tangent graph is this slight S curve, and that is always the shape of a tangent graph. It will always approach the asymptotes on the left and right side. And our period length is going to be from this asymptote over to this asymptote. So if we evaluate the period, our equation was pi over b. In this case, b is 1. So pi over 1 is just pi. And so the distance between my two asymptotes, or really the domain of my graph, is actually 1 full pi length. From negative pi over 2 to positive pi over 2 is 1 pi, and that is my period length or cycle of this graph. And so there is not an an amplitude, because there is no maximum value. It will continue to go on and approach infinity up here. There's no minimum, because this graph will approach negative infinity down here, and so really there's no amplitude of tangent functions. This is the information you need to graph. So let's do another one. Try and simplify everything so we can really visualize it. Alright, so let's graph 3 times the tangent of pi over 2x. Here's our a value, here's our b value. So I drew some asymptotes here, and I'm going to come up with the equations or locations of those asymptotes. We use pi over 2b to get the asymptotes. So b is going to be pi over 2, so pi, oops, too big. Pi divided by 2 times pi over b. So on the bottom we're going to get, what? That should be a 2. I don't know what I'm doing here. pi over 2 times pi over 2. This is our b. Alright, so on the bottom we get 2 pi over 2, which reduces to just pi. So now we got pi over pi, and that reduces to just 1. So the right asymptote is going to be at x equals, that would be the equation of our vertical asymptote, x equals 1. So right here is positive 1, and I know that my left asymptote is going to be the same but just negative, so it's going to be an x equals negative 1. That would be the equation of this vertical line. The next step would be to find the midpoints. The midpoints are going to be pi over 4b and a. There's our x, y value. So pi over 4b would be pi over 4 times the b value, which is pi over 2. So that ends up being 4 pi over 2 on the bottom, which reduces to just 2 pi. So we have pi over 2 pi. Well, those will reduce. So our x value is 1/2. The y value is going to be the a value. Here's our a value, it's positive 3. So our midpoint location is going to be at 1/2 or 0.5, 3. So right up here is going to be the midpoint location. So that means that the left midpoint is going to be the same but the opposite. So that's going to be a negative 1/2, negative 3 coordinate. So about right there, if that was negative 1/2. We know that the x-intercept is always going to be right in the middle of our asymptotes, and so in between negative 1 and 0 is 0. So right there is the midpoint. And we now have everything we need to graph, but I'm going to talk about the period length real quick. Period is going to be pi over b. So in this case it's going to be pi over 2, that's our b value. So if I flip and multiply, we get 2 over pi is what we're multiplying by. Pi's will go away, so our period ends up being 2. Well, from negative 1 to 0 is 1, and from 0 to 1 is 1, so this full period length is actually 2. That is correct. What we got to do now is draw the shape of our graph. We know that it's going to come down and approach this. So it's going to come down and approach that asymptote forever, right? It's going to come up and approach that. Kind of sort of like this. There we go. A little messy. But there's essentially the graph of our tangent function. And now because it got so stretched here, the S-curve is a little hard to see, but really that's the shape of our graph, right? Little slight S-curve. And yeah, that's the tangent graph. A little messy there, sorry. I got some time, I can make it a little neater in the next minute here. So if you find that when you graph it, you lose that S-curve, just change your Y value intervals there so that it's not so stretched. So what I'm going to do here is I'm going to make this 3 and this negative 3 right there, and then we'll be able to see it stretch a little bit easier here. So now we can really see this slight S-curve. There we go. A little bit better. There is the shape of our tangent graph. So again, find your asymptotes first. Those will be kind of the boundaries of your graph. I like to think of this as being inside a little cage based on the bars of our asymptotes. Find your midpoint values. Your x-intercept is going to be in between each of your asymptotes, and then if you just connect those dots, you should end up with a nice little S-curve for your tangent graph. Alright, good luck graphing tangent functions.